Do not connect neutral to ground. Connecting neutral to ground can be extremely dangerous and can cause electrical fires or shock hazards. The neutral conductor is designed to return current to the source, while the ground conductor is designed to protect against electrical faults. By connecting them, you can create a path for current to flow through the ground wire, which can overload the circuit and cause a fire. Here are some troubleshooting steps. Firstly, ensure safety first. Turn off the power to the circuit at the breaker panel before attempting any troubleshooting. Secondly, check the receptacle wiring. Ensure that the hot, neutral, and ground wires are properly connected to the receptacle. Look for loose connections or damaged wires. Thirdly, test receptacle voltage. Use a multimeter to verify that the receptacle is receiving proper voltage from the circuit. Fourthly, trace the neutral wire. Use a wire tracer or continuity tester to trace the neutral wire from the receptacle to the recessed fixtures and ceiling fans. Check for breaks or loose connections. Fifthly, check switch wiring. Inspect the wiring at the 3-way, 4-way, and wall switches. Ensure that the wires are connected correctly and that there are no loose connections. Sixthly, check fixture connections. Remove the trim or cover plates from the recessed fixtures and ceiling fans. Check that the connections between the fixtures and the wiring are secure. Seventhly, disconnect fixtures. Disconnect one of the recessed fixtures or ceiling fans from the wiring. Test the remaining fixtures to see if they work. If they work, the problem is likely isolated to the disconnected fixture. Eighthly, call for professional help. If you cannot identify or resolve the issue, it is best to call a qualified electrician to diagnose and repair the problem safely. It is not recommended to use the ground as a temporary neutral fix. This can be dangerous and can lead to further electrical issues. Instead, turn off the circuit at the breaker panel and leave the lights off until the issue can be resolved properly. The presence of voltage on both the hot and neutral wires, especially when the neutral should ideally be at or near 0 volts relative to ground, strongly suggests a break or high resistance in the neutral conductor. This condition is what is typically referred to as an open neutral. When the neutral connection is compromised, the electrical devices connected to the circuit, like lights and fans, cannot complete the circuit back to the power source properly. Instead, the voltage seeks an alternative path, often through the grounding system or other unintended paths. This can lead to the neutral wire appearing to be energized, as voltage bleeds onto it from the hot side through the connected loads. The fact that the receptacle is working correctly while the lights and fans are not is a critical clue. This suggests that the open neutral is likely located downstream from the receptacle, meaning further along the circuit towards the lights and fans. If the open neutral were located before the receptacle, it is likely that the receptacle would also not function correctly. To systematically troubleshoot this issue, it is important to follow a logical process to isolate the location of the open neutral. Firstly, confirm power is off. Even though you've already tested and observed the voltage readings, it's crucial to reiterate the first step of electrical troubleshooting, which involves ensuring the power to the affected circuit is completely turned off at the breaker panel. This is a non-negotiable safety measure. Secondly, inspect the receptacle box. Carefully remove the receptacle from its box and thoroughly inspect all wiring connections. Look for any signs of loose wires, corroded terminals, or damaged insulation. Pay close attention to the neutral wire connection at the receptacle. Even if it appears connected, gently tug on it to ensure it is firmly secured. A loose neutral wire at this point could be the source of the problem, or it could indicate a problem further down the line. Thirdly, trace the circuit path. Since the issue is likely downstream from the receptacle, you'll need to trace the path of the circuit to the lights and fans. This may involve accessing junction boxes, switch boxes, and the fixtures themselves. Use a circuit tracer if available. A circuit tracer can help you identify the specific wires associated with the affected circuit, making it easier to follow their path through the electrical system. Fourthly, examine switch connections. Given that the lights are controlled by a combination of 3-way and 4-way switches, it is essential to inspect the wiring at each of these switches. Incorrect wiring or loose connections at any of these switches can disrupt the neutral path and cause the observed symptoms. Pay particularly close attention to the common terminals and the three-way switches, as these are often involved in carrying the neutral current. Fifthly, check fixture connections. At each light fixture and ceiling fan, carefully inspect the wiring connections. Look for any signs of loose wires, improper connections, or damage to the wiring. In recessed lighting fixtures, the connections are often made inside a junction box located above the fixture. Ensure that these connections are secure and properly insulated. Sixthly, test for continuity. Using a multimeter set to the continuity setting, test the continuity of the neutral wire along its path. Disconnect the neutral wire at both ends of a section of the circuit, and then use the multimeter to check for continuity between the two ends. If there is no continuity, this indicates a break in the neutral wire within that section. Seventhly, check for voltage drop. If you suspect a high resistance connection in the neutral wire, you can use a multimeter to measure the voltage drop across the connection while the circuit is under load. Turn this circuit breaker back on and then measure the voltage drop between 2 points on the neutral wire, one on either side of the suspected connection. A significant voltage drop indicates a high resistance connection. Eighthly, address identified issues. Once you have identified the location of the open neutral or high resistance connection, take the necessary steps to correct the problem. This may involve tightening loose connections, replacing damaged wires, or re-terminating connections. Ninthly, verify proper operation. After making any repairs, turn the circuit breaker back on and verify that the lights and fans are now operating correctly. Use a multimeter to check the voltage at each fixture and switch to ensure that the neutral voltage is near 0 volts relative to ground. It is critically important to avoid creating a neutral to ground bond. Intentionally bonding the neutral to ground downstream of the service entrance creates a parallel path for neutral current to flow through the grounding system. This can have several dangerous consequences. Firstly, ground fault circuit interrupters, or GFCIs, may trip. GFCIs are designed to detect imbalances in current between the hot and neutral conductors, which can occur when current is flowing through an unintended path, such as the grounding system. Bonding the neutral to ground can cause GFCIs to nuisance trip, interrupting power unnecessarily. Secondly, elevated ground potential. When neutral current flows through the grounding system, it can raise the potential of the ground wires relative to true earth ground. This can create a shock hazard, as people or equipment that come into contact with the grounding system may experience a voltage difference. Thirdly, electromagnetic interference. Neutral current flowing through the grounding system can create electromagnetic interference, which can disrupt the operation of sensitive electronic equipment. Fourthly, code violations. Bonding the neutral to ground downstream of the service entrance is a violation of most electrical codes, including the National Electrical Code, or NEC. Such violations can result in fines or other penalties. If temporary lighting is needed, consider using battery-powered lights. If temporary lighting is absolutely necessary, the safest option is to use battery-powered lights. These lights provide illumination without requiring any connection to the electrical system, eliminating the risk of electrical shock or fire. If the homeowner has battery-powered lanterns, flashlights, or LED work lights, these can be used to provide temporary lighting until the electrical issue can be resolved. If battery-powered lights are not available, consider using a generator to power temporary lighting. If a generator is used, it is important to follow all safety precautions, including properly grounding the generator and using appropriately sized extension cords. Additionally, ensure that the generator is located in a well-ventilated area to prevent carbon monoxide poisoning. The NEC is a comprehensive set of standards and guidelines for electrical installations in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Following the NEC is essential for ensuring the safety and reliability of electrical systems. Article 250.4. A5 of the NEC specifically addresses the issue of grounding the neutral conductor. It states that the neutral conductor shall be grounded at the service entrance and at the source of a separately derived system, but shall not be grounded elsewhere in the distribution system. This requirement is intended to prevent the creation of parallel paths for neutral current to flow through the grounding system. Article 250.24 of the NEC provides detailed requirements for grounding the neutral conductor at the service entrance. It specifies the size and type of grounding electrode conductor that must be used, as well as the methods for connecting the grounding electrode conductor to the grounding electrode system. Article 310.15 of the NEC provides requirements for determining the ampacity of conductors. The ampacity of a conductor is the maximum amount of current that it can carry safely without overheating. The NEC provides tables and formulas for calculating the ampacity of conductors based on their size, insulation type, and installation conditions. Article 406.3 D of the NEC addresses the installation of receptacles in damp or wet locations. It requires that receptacles installed in these locations be of the ground fault circuit interrupter, or GFCI, type. GFCIs are designed to protect people from electrical shock by detecting imbalances in current between the hot and neutral conductors. Article 408.3 D of the NEC addresses the identification of grounded conductors or neutral conductors. It requires that grounded conductors be identified by a continuous white or grey color. This requirement is intended to help electricians easily identify the neutral conductor and avoid accidentally connecting it to the wrong terminals. Electrical safety is paramount when working with electrical systems. Firstly, always energize the circuit before working on it. The most important safety precaution is to always energize the circuit before working on it. This means turning off the circuit breaker or removing the fuse that supplies power to the circuit. Use a voltage tester to verify that the circuit is de-energized before touching any wires or terminals. Secondly, use properly insulated tools. When working on electrical circuits, it is essential to use tools that are properly insulated. This will help protect you from electric shock. Look for tools that are marked with the UL or Underwriters Laboratories or ETL or Intertic listing mark, which indicates that they have been tested and certified for electrical safety. Thirdly, wear appropriate personal protective equipment, or PPE. Wear appropriate personal protective equipment, or PPE, such as safety glasses and rubber gloves, when working on electrical circuits. Safety glasses will protect your eyes from flying debris, and rubber gloves will provide insulation against electric shock. Fourthly, avoid working in wet conditions. Water is a good conductor of electricity, so it is important to avoid working on electrical circuits in wet conditions. If you must work in a damp area, take extra precautions to protect yourself from electric shock, such as wearing rubber boots and using a ground fault circuit interrupter, or GFCI. Fifthly, know your limits. If you are not comfortable working on electrical circuits, it is best to call a qualified electrician. Electrical work can be dangerous, and it is important to know your limits and avoid taking risks. Remember, safety should always be the top priority when working with electricity. Take the time to follow these safety precautions, and you can help protect yourself from electrical shock and other hazards. If the troubleshooting steps outlined do not lead to a solution, seeking the expertise of a qualified electrician is paramount. A licensed electrician possesses the knowledge, skills, and equipment necessary to diagnose and repair electrical problems safely and effectively. They can conduct a thorough inspection of the wiring, identify any hidden issues, and ensure that all repairs are performed in accordance with electrical codes and safety standards. Attempting to fix complex electrical problems without proper training and experience can be dangerous and may lead to further damage or injury. Therefore, when in doubt, it is always best to consult with a professional electrician.